All right, so this is going to be the pre-calculus final exam review. We'll take a look first at numbers 1 through 5. I'm going to start with number 1 by converting 7 pi over 8 into degrees. So to convert something into degrees, I'm going to multiply by 180 over pi. And I remember that because in degrees, I'd like for my pi's to cancel out. So I would need to have one of the pi's on the top and one of the pi's on the bottom so that they'll cancel out. And so now with my fraction, I'm going to do 7 times 180 up there on the top gives me 1260. And on the bottom, I'm going to have 8. So 1260 divided by 8 gives me 157.5 degrees. On number 2, then, we're going the opposite direction. I'm going to take my 115 degrees, and I'm going to change this one into radians. So generally for radians, we want to have pi in the numerator, and so I'm going to multiply by pi over 180. So just the opposite of what we did there on number 1. So I'm going to take my 115 pi over 180, so top times top, bottom times bottom. And I'm going to do a little bit of reducing with my fraction here, and I'm going to let that be 23 pi over 36. And remember that radians doesn't have a symbol. We can leave that just exactly the way that it is. All right, on number 3, we're trying to determine two coterminal angles that go along with 3 pi over 8. So for coterminal angles, let's go over here on the side and make a little note real quick. So coterminal angles, we want to have the same exact terminal side or the same finishing side, just wrapping kind of all the way around the circle. And so when we talk about all the way around the circle in degrees, we're going to be talking about adding and subtracting 360 degrees. And if we're working in radians, we're talking about adding and subtracting 2 pi. And so this one tells me to get two coterminal angles, so I'm going to add 2 pi since we're working in radians here, and I'm going to subtract 2 pi. So let me start by adding 2 pi. So 3 pi over 8 plus 2 pi. I'm going to need a common denominator on that. So 2 pi with a denominator of 8 is going to be 16 pi over 8. And add those together, 19 pi over my common denominator of 8. So there's one coterminal angle. And then to get the second coterminal angle, I'm going to take my 3 pi over 8 and I'm going to subtract 2 pi. And so same common denominator here. This time we're just subtracting 16 pi over 8. And so that will give me negative 13 pi over 8. And you can leave those right there in radians. So if you're given a question in radians, add and subtract 2 pi. If you're given a question in degrees, like we are on number 4, I'm going to add and subtract 360. So with my degrees here, I'm working with negative 36 degrees. So I want to find two coterminal angles that go along with negative 36 degrees. So I'm going to start with adding my 360 degrees. So negative 36 plus 360 is going to give me 324 degrees. And then negative 36 degrees. Now I'm going to subtract my 360 degrees. So again, all the way around that circle until you have the same terminal side. And that's going to give me negative 396 degrees. Be sure you use a degree symbol on those since we're working in degrees. All right, and finally for this part of the video, on number 5, I've got a sprinkler that's on a golf course fairway that's set to spray water over a distance of 70 feet and rotates through an angle of 120 degrees. And I want to find the area of this thing. So this kind of goes all the way back to when we were talking about the law of sines and the law of cosines. And so let me start by drawing a triangle here. So this thing is going to spray 70 feet, and then it's going to rotate around. And it's going to also spray 70 feet in this direction. Looks a little bit like this. So this one's going to be 70 as well. So that spray hasn't changed even though it's moved. And then it tells me that it's rotating through an angle. So here's my sprinkler right here. So it's going to rotate right here through an angle of 120 degrees. All right, so on that triangle, we are working with given information on side, angle, side. So I'm going to use my area formula. That looks like 1/2 times A times B times the sine of C. And remember that those letters right there are kind of interchangeable. You can use those in any order that you need to. And so in this case, I'm going to say that I've got a side A here, and I've got a side B here. and this is going to be my angle C right here. So whichever two sides an angle you're given, we're going to plug those into our formula. So my area then is going to be 1/2 of 70 times 70 times the sine of 120. Now notice that they gave us that angle in degrees, and so let's check and make sure that your calculator's in degree mode first. That's very important. Mine's in radians. Let me switch over to degrees real quick. Turn that on. So switch over to degrees. I'm going to push mode and then move over to degrees, and then I'm going to second quit to get back out of that screen, and so I'm going to put into my calculator 0.5, so 1/2 times 70 times 70 times the sine of my 120 degrees. So just be sure anytime you're given something in degrees that you work in degrees, or if you're given something in radians that you work in radians. And I'm around to 3 decimal places, so that will be 21, and I'm around to 3 decimal places, so 0.762. And they told me that we were working here in feet, so my units of measure are going to be feet squared since we're working with area.